You look at the night sky and feel infinite possibility. Somewhere out there are other worlds, other stars, maybe even other civilizations waiting to be discovered. And one day, humans will reach them. That's what you believe. That's what we all believe. But there's a problem. A problem so fundamental, so deeply woven into the fabric of reality, that it might trap humanity on this single planet forever. Not because we lack the will, not because we lack the technology, but because physics itself has locked the door, and we might not have the key. Let me show you why. First, you need to understand something most people get wrong about space. We don't actually understand how big it is. We say, very far. We look at numbers and nod like they make sense, but they don't. Not really. In 1969, astronauts traveled to the moon at 40,000 kilometers per hour. The fastest thing humans have ever built is a tiny probe called Parker Solar Probe. It uses gravity from Venus like a slingshot, getting faster and faster each time it swings around. After years of this, it's now traveling at 635,000 kilometers per hour. That's fast enough to circle the Earth in just 4 minutes. Imagine a spaceship could match that speed. Where could we go? Mars would take 2 weeks. Great. Pluto, one of the most distant things we call part of our solar system, would take about a year. Getting longer, but still manageable. You could do that, retire, tell your grandkids about the time you went to Pluto. But then you want to leave the solar system. You aim for the Oort cloud, that fuzzy outer shell where icy objects drift in the darkness, marking the true edge of our solar system, where the sun's gravity finally lets go. How long does it take? 2,500 years. Let that sink in. From the founding of the Roman Republic to right now, this moment. That's how long you'd spend just escaping your home. You'd never see Earth again. Neither would your children, nor their children, nor anyone alive today. The journey would take as long as the entire history of Western civilization. And when you arrive, there's nothing there, just empty space, the invisible barrier. So what if we go faster? This is where human ingenuity comes in. What if we built a spaceship powered by nuclear fusion? What if we could reach 20% the speed of light? That's 216 million kilometers per hour. Impossibly, absurdly fast. Suddenly, the math gets better. Alpha Centauri, the closest star system to Earth, is about 4.4 light years away. At this speed, you could reach it in just 20 years. 2 decades. Not great, but survivable. Your grandkids could be born on an alien world. Think about what this means. We're not talking about far-flung galaxies anymore. We're talking about our neighborhood, the closest star. 1 trip, 20 years in a box with recycled air and freeze-dried food, and you've reached somewhere genuinely new. For the first time, deep space exploration feels possible. And then physics steps in and laughs at us. Space isn't empty. This is the part that destroys every dream. Floating through the void are atoms. Individual atoms, dust particles, tiny pebbles. Things so small you wouldn't notice them on Earth. You wouldn't even feel them. But at 20% the speed of light, an individual atom becomes a bullet. A grain of dust becomes an explosion. Imagine running toward a wall at full sprint. The impact hurts. Now imagine running that same direction, but somehow you're moving 1,000 times faster. The impact doesn't just hurt. The impact shatters your bones. At extreme speeds, the impact doesn't just shatter bones. It vaporizes you entirely. A single grain of dust hitting your spaceship at 20% light speed releases the energy of a grenade explosion. It doesn't just chip your hull. It carves a hole. A microscopic hole, sure, but a hole nonetheless. Over time, your ship becomes riddled with puncture wounds, like a sieve. Your atmosphere leaks out. You die. A pebble the size of a golf ball? That releases more energy than the nuclear bomb dropped on Hiroshima. A single pebble. Gone in an instant. Your ship, vaporized. Everyone aboard, dead in less than a second. So engineers say, we'll build armor, a protective shield, a sail that absorbs or deflects most particles. And yes, this helps. But it adds weight, and weight needs fuel. And fuel needs more weight to carry it. The equation gets worse and worse. There's another problem. You can't see the danger coming. At these speeds, even light doesn't reach you in time. By the time a sensor detects a pebble, you've already hit it. There's no time to dodge, no way to prepare. We might have found our speed limit, not because we don't know how to go faster, but because faster means dead. But let's say we solve this. Let's say we have a ship made of something impossible, something indestructible that can somehow survive the journey. You arrive at Alpha Centauri after 20 years. Your message is recorded, sent back to Earth. It takes 4